Physiological properties of heart muscle. Heart muscle is different than skeletal and smooth muscle because it has certain properties, and those properties make the heart muscle different than other muscles. So those are the properties of the cardiac muscle. One property is contractility, the ability to contract. You know that heart muscle contracts involuntarily. It doesn't listen to your command, right? Involuntary contraction. Not only that, it contracts continuously, right? So the contractility of heart muscle is different than other muscles. Autorhythmicity. Auto means self, rhythm is regular interval. So autorhythmicity is the property of heart that it beats in regular interval, maintaining the interval. Now look at me. Your heart beats like this, right? It doesn't beat like few times fast, then very slow, then fast. No, right? It maintains the interval, right? So that is autorhythmicity in rhythmic way. Conductivity. Inside the heart, you have the conductive system, and the conductive system transmits and generates electrical impulse or electricity. So, in the heart muscle, you have a conductive system, and that conductive system produces and transmits electricity. We'll talk about the conductive system later, just know that. Syncytium. Your heart muscle works as an unit, single unit, which is very important for the heart muscle. All heart muscle fibers are connected to each other. Like these are the heart muscle fibers. Just know that they are connected by two types of junctions. Desmosome, you have learned about these junctions before, and gap junctions. In gap junctions, you have many pores or channels. And desmosomes, if you remember from NP1, I mentioned, desmosomes hold the cell members like zipper in your cloth, very strongly like this. Zipper-like, connection, very strong. So all heart muscle fibers are attached very strongly. Make sense? Number one. Number two, because of gap junctions, many gap junctions, ions can quickly move from one chamber to another. So they can communicate very fast because the doors are open. Make sense? So because of those two types of junctions, all heart muscle fibers work together quickly at the same time. And that property is called syncytium. Make sense? So all muscle fibers work very fast and together quickly. So nobody can tell I will not contract. Make sense? Everybody has to because they are attached strongly and connected chemically. Make sense? So that is the syncytium. Next one, instead of absolute period, please change that word to refractory. period. Okay. Refractory period is another important property of cardiac muscle. What is that? Refractory period has two parts, absolute and relative. Okay. So refractory period has two parts. Absolute is the first part and relative is the last part. Absolute refractory period or time is about 200 to 250 millisecond. That period is called absolute refractory period. What is this and what is this? First, know that refractory period is the time when heart will not respond to another stimulus during its contraction. Let me now show you. This is your heart. Heart is contracting, okay? And if I give another stimulus from outside, heart will ignore it. Make sense? Which is very important. Otherwise, if heart listens to everything, right, and stop contraction, that will be dangerous, right? The heart should not listen to anything else. I am contracting now, I want to listen, okay? Make sense? So, during the first 200 to 250 millisecond of its contraction, that means the first part of contraction, if you give any kind of stimulus, heart will completely ignore it. Absolutely. Heart will absolutely not listen to it. Make sense? So that's why it is called absolute refractory period during the first part of contraction, 200 to 250 milliseconds. Make sense? And during that time, 80% blood goes out. How much? 80%. So it is safe, right? Heart will not listen to anything. Sometimes, external stimulus can go to the heart, wow, but heart will not listen, will ignore that. Okay. Now, that's why it is called absolute refractory period. Not listen at all. The relative refractory period is the end part of contraction. So 250 millisecond is done. Now the last part, only 20% blood goes out during that time. If the stimulus is weak, heart will ignore. If it is strong, heart may listen. Make sense? So that's why it is called what? Relative, right? Makes sense.
20% blood, you said?
20% blood gets out during that time, okay? So it is, not dangerous if heart listens to any strong stimulus because 80% blood is out, right? So it is safe. So that's why it is called relative. If the stimulus is strong, heart may respond. If it is weak, heart will not listen. Make sense? So that's why that part is called the relative refractory period. And absolute refractory period is very important because during that time, heart should not listen to anything. Elasticity is the ability to recoil. You all know elastic things, right? Mm-hmm. You use in your clothes. That is very important to understand. That, like you bought, a pant or a shirt, and that has elastic thing. Now your size got big, like your size doubled, your body size, right? If you continue wearing that, what will happen? Eventually the elasticity will be lost, right? You'll see it doesn't, recoil. If you press too much pressure on it, right? Repeated pressure, if you keep it, then it will lose the elasticity. So heart muscle is very similar to the elastic thing. It will expand and contract, recoil. That is happening all the time, right? Heart is contracting, expanding, contracting, expanding. That's the elasticity. Make sense? Recoiling. Now, if you put too much pressure continuously for a long time, on the heart muscle, then what will happen? Elasticity will be lost. Done, right? Like that cloth you are using, putting too much pressure, right, every day, eventually the elasticity will be lost. Same thing happens in your heart. Your heart, if the blood pressure is too high for a long time, okay, many years, then heart is continuously taking too much pressure. Make sense? And eventually heart will get bigger, 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 like elastic thing, right? And will not be able to recoil. Will not be able to contract forcefully. Make sense? It will contract like this, not forcefully. Heart will be big, but will not be able to contract. Make sense? So that is called what? Heart failure. That is heart failure. The elasticity of the heart muscle is lost. Make sense? So big heart, like the elastic thing in your cloth, will stay big, right? But it will not be able to recoil. So heart will stay big. In heart failure, we see big heart, size is big, but it cannot contract forcefully. So that is the heart failure. Failure. Okay. There is a law to indicate the elasticity, that is called Frank-Starling law. Frank-Starling's law says that length is proportionate to the pressure or tension. Very simple law. Frank-Starling's law. You see, if I put more pressure, the length will increase more proportionately. Very simple. But there is a but here. The condition is within physiological limit. There must be a limit. Physiological limit. Same thing like the elastic thing you use in your clothes. If you put too much pressure, right? First, if you want to expand, look at me. You will put more pressure. It will get longer, 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 right? But if you keep doing that, at one point, it will lose the elasticity, right? And even if you leave it, it will not get recoiled. Same thing. That's the limit, physiological limit. Everything has a limit. Okay. So that's the Frank-Starling's law. Within the physiological limit, cardiac muscle will show elasticity. More pressure, increase length. Okay. Action potential of the heart muscle. We talked about depolarization, repolarization when we talked about muscle contraction in LP1.
Is this a continuation of the heart muscle physiological properties, this slide?
It is the how the contraction occurs, the mechanism of contraction. So yes. So now this is the heart muscle fiber, and if the heart muscle wants to contract, what should happen first? Remember, inside the cell of the body, your potassium concentration is always high and sodium concentration is low. On the outside of the cell or fiber, sodium concentration is always high and potassium concentration is always low. That is normal resting condition in all the cells of your body, okay, including your heart muscle cells. We talked about this before when we talked about the neuromuscular junction. Okay, now when the signal comes that heart muscle will contract, what happens? The sodium channels get opened in the cell membrane. Now you tell me, this is an easy question. If sodium channel gets opened, okay, sodium, which way the sodium will move? Chemicals always move from high to low, right? So from outside to inside, sodium will get in. Make sense? Very good. So when signal comes to the heart muscle will open the sodium channels, and that will cause the influx of sodium. So sodium will get in. Now, if I want to draw the changes here in the heart muscle, before sodium channels are opened, this is the condition, resting membrane potential. In resting condition, membrane potential. Okay? Now this way is positive. If I want to show this way positive, this way negative. Okay? And I'm looking inside the muscle fiber, inside the cell. Now you tell me, when sodium channels get opened, sodium gets in. Sodium is positive or negative? Positive, right? So positive gets in. Is it clear? And I'm measuring the change inside. So this will move which way? Up. Because this way is positive. I'm showing positive change, right? So that is called depolarization. Depolarization. Due to influx of sodium. Ion. Entrance of sodium ion. Then what will happen? Sodium channels will get closed. You see here. This is the influx of sodium. So it will go up. Number one. Number one is sodium influx, okay, through the voltage gated sodium channel. These sodium channels are called voltage gated, and remember there are two types of sodium channels, voltage gated and non-voltage gated. Voltage gated ones open abruptly, suddenly. So all the channels will suddenly get open. So a lot of sodium will suddenly rush in, will get in. Make sense? So that's why you'll see this rise is very sharp rise, because a lot of sodium suddenly gets in. And then what will happen next? Sodium channels will get closed. And so let me draw here. Sodium channels got closed here, but two other channels will get opened. One is potassium channel. Now you see here, potassium is low outside. It's opposite of sodium. So when potassium channels get open, potassium will do what? Get out. Because potassium is low outside, right? High inside. Yes. The potassium will get out. So potassium gets out. But at the same time here, another thing happens. Another type of channels get opened, calcium. And calcium, remember, will get out. So two things happen in second phase. Potassium gets out. Calcium will get in. Sorry. Potassium will get out. Calcium will get in. Okay. So calcium will get in. Potassium will get out. Okay. Now both are positive. So you tell me, if one positive gets in, one positive gets out, what will happen? Almost no change. Make sense? Because one positive is getting in, one positive is getting out. So potassium gets out, calcium gets in. And that's why in this part, second part, you see almost no change. This part is called plateau. Plateau, okay, where the membrane potential will remain same, okay, because of influx of potassium and influx of calcium. And then what will happen? The calcium channels will get closed, more potassium channels will get open. So more potassium will get out. So now you see in stage 3, calcium is closed, right? Who is only getting out? Potassium. Make sense? So now if lot of potassium, which is also positive, which is also positive, potassium is getting out, that means inside what will happen? Will move towards negative, less positive. Make sense? Because positive is getting out. So it will go this way. Since the positive is getting out, positivity will go down inside the cell. And this part is called repolarization. Repolarization. Due to efflux of potassium. Okay? And this one is efflux of potassium but influx of calcium. And this one is influx of sodium. So, is it clear? This part is only seen in cardiac muscle. That's why you need to know the action potential of cardiac muscle. This part is present in the heart muscle. In a skeletal muscle, you'll see like this. No plateau. Now, another thing you need to know, why we need depolarization? Because depolarization causes contraction. Contraction. And repolarization causes relaxation. Okay? That is important to know. Otherwise, what's the meaning of depolarization? Depolarization, right? Depolarization causes what? Contraction. And repolarization causes relaxation. So this is depolarization, this is contraction. This is repolarization, this is relaxation. Okay? So, first depolarization should occur in the cardiac muscle, that will cause what? Contraction. Then repolarization should what? That will cause relaxation. Now, what this part does, plateau, heart contracts, right? And then you need what? Little bit interval before it relaxes. You know that. That's the rhythmic contraction and relaxation, right? So that interval is given by the plateau. This is contraction, this is relaxation, but in between you need what? Little bit what? Interval, time, right? So look at this, contraction, then a little bit time, relaxation, right? Then contraction, relaxation. So that time is given by that plateau. Okay? It's very important. Okay, so let's stop here. That is the action potential of cardiac muscle and why it is important.
After class, I need to go back.